Hello guys, welcome back again. Now we are just gonna do the very final, video and tutorials for our wonderful journey, which was writing multi-level hierarchical models in the Bayesian analysis. Now, in order to do that, we were able to find the list as an input for our stand function. The thing that we are just going to do, we are just going to finish, the stand model as I promised before. And now in order to do that, I'm just going to open a text file. And I'm just going to call that, let's say, for example, save it as let's say, model E underscore AD dot stand. That's crucial, as you learned so far, to just end your file with the stand. And I'm just going to go back to just copy paste whatever I have created on the prior model, previous tutorials, take it back to, the new file, and just add additional required, adjustments for my model. The first thing which we are just going to look into is going to be my data block. You remember that the thing that we discussed was that our data block should match one by one, all the elements that we have defined before. In the previous tutorials, we add 3 levels, which it was, the gender, education level, and socioeconomic status. And I'm just going to add all these, 6 new objects into my data model. It's a systematic approach. The first thing is going to be, we talked about the gender, we called the objects M. As you look at here, you remember that the object that we called, it was M. Let me take it next to this one here. And for the M, you remember that it was called, for the M, it was, for our gender. I'm just going to skip writing the description in order to save time of the recordings, because we are just going to add 6 objects. Please make sure that you add the descriptions here as I'm just move along. I skip the writing in order to save the time to just move on as quickly as we can. And you remember that when we define this, we are just going to call it as an integer, that for the M, the number of the integers that we have created here for the M, you remember that it becomes the lower, it becomes 0. That's the convention that we have. And also, the second that we created here, it was the MF, and we created the MF as a tagging for all the 372 observations. I'm just going to call MF. I know that I have n observations in my model. I'm just going to put, the semicolon next to that. And I'm just going to know that it's going to be an integer with the lower, which reasonably is going to be 0, but the upper one is going to be equal to the number of the levels which I created for the gender, which is going to be called M. And one tiny space between these arguments and this one, it just gives me, the tagging for these new F. I'm going to go back again to the file which I created, the list. I see a new object there. I know that I have to introduce the same object here. It's going to be E, which shows the level of, the number of the levels within the education, predictors, which it shows variation between each observations. I know, as before again, it has to be an integer, which it takes the lower equal to 0 as 0 levels between them, and I'm done with it. And now I know that I created another object, which is called educ, which is going to be the tagging, for the people in all 373 observations, that we give them an ID and the tag, which shows that the level of the educations that they have. Remember that in order to do that, we had to factorize it, and before that, we have to categorize it by using the find interval function. And I know that I have n observation there. I put the semicolon there, and I'm just going to create an integer with the lower equal to 0 and the upper, which equals to the number of the levels within the education level, which I defined it as E on the previous slide. And also, I have 2 more objects to add for the socioeconomic status. One of them is going to be the S, which refers, to the level of, socioeconomic status, the number of the levels within the socioeconomic status that they show their variations. And you see how that we created. I know that it's going to be an integer with the lower, which it has to be equal to 0, S. And also for the tagging, I do not forget that I created this object, SES. I'm going to go back to my model. I know that the SES is going to be the tagging that for any 373 observations that I have, I know that what socioeconomic status that they are in, and now I'm just going to know that it's going to be an integer, which the lower is going to be 0, but the upper has to be equal to the number of the variations within the socioeconomic status, which is going to be the S, as I created that before. And now I go back to that list which I created. I notice that I have every single element in the list in the R reflected on the data block in the stand block in the stand file which I have created. Make sure to save your file, not to lose anything in case something happens. Now I'm just going to go back to make necessary changes into the parameters which I have. Remember, for any level of the hierarchy which you create, you are just going to have a distribution which is going to be random and changing both for the intercepts and the slope. And when it comes to the parameter, we are just going to show that excuse me, in our parameters, those kind of distribution. You refer to, I should say, distribution of change with, I should say, the group level, doubly represented as you see on the CDR level. And now we are going to, for example, create Z, which reflects, I should say, the distribution within, I should say, the gender. I'm just going to call that, I should say, as a matrix, which gets 2 dimensions, 2. And the number of the row, it's going to be M, which we created before in the data. And now it shows that, okay, it's going to be the distribution that we create. Row number 1 refers to, I should say, the changing, I should say, intercepts. And 2 refers to changing of the slope. And for the standard deviation, I'm going to call this one sigma of Z, which I know that if the above is going to be the matrix, this one is going to be the vector, I should say, which the lower of that is going to be equal to 0 because that's the standard deviation. And I know that the vector which I have, essentially it gets the dimension of the number of the levels of the variations within the gender, which is going to be M. This one is going to essentially be the distribution which it needs to be taken into account for as a gender. However, we are also added one level of the hierarchy, which it was for the level of the education. Let's call for the level of the education the distribution as V. And I know that this one again has to be a matrix of 2 rows. Row number 1 for the changing intercepts, row number 2 for the changing the slope, and the number of the features, the columns, is going to be the number of the levels which they varies within that group. For the education, you saw that it's going to be the E. And also, you remember that then the sigma, if I may call that the V, is going to represent the standard deviation, which takes the form as a vector, which it comes as, because it's the standard deviation and it has to be positive, then I add the arguments as the lower should be 0, but I know that the elements inside that vector, it's going to be E, which is going to be the E which we created above as the number of the levels, varying levels within, I should say, education feature. Now, we have one more last level of the hierarchy which we added into our model, which essentially it was the socio-economic stances. I may just call that, I should say, the level of the socio-economic stances as small s. We can call that, let's say, P, that you do not get it confused. And now the P, you know that it's going to be a matrix with 2 rows. Row number 1 changing intercepts. Now number 2 changing the slope. The number of the features is the number of the levels that they are going to change. I'm going to call it S, as we called it before at the data block S. And also, I know that I can just define the standard deviations for these randomness as sigma P. I know that because I had a matrix before, it's going to be called as a vector, which, because it's a standard deviation and it has to be positive, then the lower it has to be, I should say, 0 as an argument. But because that's the vector, it has to come with a length. The length is going to be the number of the elements which I created within, I should say, the socio-economic status, which is going to be the S. And that's essentially, that's all the changes which we had to just add into our parameter space. You see that it's a very systematic way to change and add additions and adjustments. Then you can extend the thing which you have learned into the hierarchical models in the Bayesian analysis using the stand function into even more than 100 level of the changes now. Okay, now we are going to go to a very essential part of our the blocks, which it has some changes, very crucial changes which we had to add into our transfer parameters because we added 3 levels of the hierarchy. For each level of the hierarchies which we add, you notice that we have to just add one intercept, one random intercept, one random slope, however, within each for loop. Okay, the first one, I call the changes, I should say, with the gender as the Z. Then as a result, when it comes to adding one more level of, I should say, one more level of hierarchy with the random intercepts, I'm going to call that Z. I know that's a matrix. Row number 1 shows the random, I should say, intercept. And I know that it has to be the MF which I created above, which it shows, I should say, the tagging which we created. The MF, which it comes with one level of the change within a for group. Then you see that I have to create an object here. We had L before here. Let's call that N. It becomes the random intercepts. Probably this one is said that the N is not recognized, and we are just going to remove that problem when we add one more for loops. And also within the random, I should say, as you're going to say, random slope, Z, it's going to be, for the case that we have here, it's going to be essentially 2, because it's 2 refers to the random slopes, and it's going to be the MF, the tagging which we created for, I should say, N. And you see that in order to define the N, I'm just going to go ahead, define another for loops. There should going to be many loops there for N small from 1 to, let's say, the changing levels of the N, which we defined it as the M. Okay, now we took care of one level of, I should say, hierarchy. I'm just going to add the second level of the hierarchy, which it was the education level. The education level in our model comes with one random or varying intercepts and one random or varying slope. In order to show that it's random intercepts, I'm just going to add one level here. I call them as the V. I know that this one comes with row number 1. For the education, we call that educ. I'm just going to get the for loops. I'm just going to call that M. Let's take it to the next line, and I'm just going to add one more level here, and I'm just going to call that the thing which I created here as V. The second row represents, I should say, the random intercepts, the random slopes. And for the educ, I tag them with educ. Then for the tag, it comes with the number of the levels which it is assigned to, which it's going to be the E in the parameter section. And the data block, we defined it. In the block, data block, we defined it. You have an error message here. It says that the M does not exist. I'm just going to, for the previous loop, I forgot to just give it the curly brackets. I'm going to give that another curly brackets. For another loop, to define, I should say, the M, to define the, for the education, it was, I should say, it's not going to be N, it has to be, for the edu, it has to be M, that's right, it's going to be 4, another loops, it's going to be for M in 1, 2, the number that we had for education, it was called E. I make sure that I have the curly brackets open here, and I'm going to close it at the end of the line that I have here. It doesn't matter where you just put the closing there. Okay, now I added M here for the educ, and I have M here. We have one error message. Don't worry, the error message is going to be gone. And let's see what just went wrong. We have UWZV. Okay, it's going to be plus. Okay, now the thing is removed now. The error message is removed because all the things that we have here, they refer essentially as their random intercepts. All the things within parentheses here, they refer to, I should say, their random slope. I'm just going to add the last change into our model, which is going to be the distribution that we just called it as the P. We have the P. I'm just going to get the random, I should say, intercepts one. It's going to be for the socio-economic statutes, and for the labeling of that, we have used everything so far. Let me call that, I should say, for example, one letter in the alphabets. Let's call that, for example, let's call that with small d. And also, I'm going to get plus. And at the end, also, I'm just going to add one more level of random intercepts, which is going to be, I should say, the P, which represents the distribution. It shows the random intercepts, random slope if I just put 2, and I have socio-economic statutes, and for the labeling, I call that labeling D, and it says that the D is not recognized. That's why I add another for loops, and I P, which is going to be from 1 to the number of the levels, which is changing in the socio-economic statutes, as we call that S. I do not forget to just add curly brackets there, and I add the next curly brackets at the very end. Okay. Let me see what is the problem here. It says that IKLNMP. It says that the loop has been created before. Okay, let's... Oh, it should not be P. It's the thing which we created, D. That's right. We have lots of loops within loops. Sometimes it becomes too confusing. That's the indexing which I called it for socio-economic status D, and that's why I had to just create D here. I make sure that I save it before I lose anything, and that's essentially just we created and adjusted our transferred parameters into our model. You see that whatever we have here, it refers to our random intercepts. All of these features have the first row in our matrix. And whatever I have between these parentheses all the way goes to the end of these parentheses here. They show the random, I should say, slope, which is multiplied to my, I should say, features, which it was the age. And that's essentially a crucial block that we had to create. And now we just go essentially to the final block that we had, which is going to be essentially for our model. We do not have to change, I should say, our likelihood because we are looking at the normality of, I should say, our model. But we can here define, I should say, for the distributions that we had. Because Z, Z, VP, I should say, are priors. We can come here to define a priors as that. We can say that, for example, Z1, which is essentially, it's the priors for, I should say, for the random slope of the distribution for the Z that we define as the gender. And now I'm just going to call it as, again, as what we have done always, that it has to be a normal, which is centered and comes with the sigma, I should say, Z, which it comes with the first element. And we took them as sigma Z1 as, I should say, a flat weakly informative prior step. It has to be Z small, and that's fine. Make sure to save it. And also, we can define the priors for the random intercepts, random slopes of our gender variation. I take it again as a normal, and it has to be centered again, and I call the standard deviation as sigma Z, but it gets number index 2, which it shows that essentially are, let me put them like get some kind of spacing. that they do not appear, I should say, as confusing. And also, another thing that we talked about the different distribution as V for, I should say, for the education level, and that's how I can show that V1, which shows that the priors for the random intercepts for the education, I call it as a centered normal with the sigma V with the index 1 for the random intercepts, and also V2, which is going to be the priors for my, I should say, random slope, which I'm just going to call that as a normal, which is centered, which is going to be the sigma of V, but the elements of the 2. Okay. 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 In that case, if you get that error, you can remove that. Then it can be considered as a flat priors for, I should say, for your random slope. And also, we go to the very final one, which we had definition for the P for the random intercepts. The priors, it can be recorded as a normal, which is centered with the sigma, I should say, P for the random intercepts, with the sigma P1 is taken as a flat priors, and also we have P for 2, which it's going to be here. Again, it's a normal distribution, which can be taken as centered distribution with the sigma P. However, it's going to be 42, and that's here. We have defined all the priors. Remember that for all the sigma U, W, Z, VP, all of them, they are going to be taken as a flat. If we get the same problems for the log posterior distribution, we can just remove this one to show that this one has to be taken as a flat priors, as our priors done. I've directly informative for those ones. I make sure that I save it as, we do not lose anything, the likelihood remains the same, and also the generated quantities, which acts as a memory for our system, for our data sets, in order to see that how we are able to replicate our observation, the power of our model in order to replicate the observation, how closely it can imitate the initial observation remains intact. And essentially, after, I should say, this tutorial, you saw that how can we systematically incorporate changes when we add one level of the hierarchy into our model. Then from now on, when you're working with the data sets that you have, if you identify a feature that you can detect any variations between different levels of that feature, you know how to just write your stand code and how to just make any changes relevant to the level of the changes within these blocks in your stand file. By doing that, I have to remind you one thing, that when you just go to your R and you just write your stand file and you choose level of the iterations and the warm-ups, and you may just go through the 4 chains to run your file, then be able to draw some posterior samples from your posterior distribution. Remember that because of all these for loops that we have, computationally, the execution, it's going to be extremely expensive, and it may take even a couple of days, or even for some people, a couple of weeks to just be able to converge your model then. It depends all on the, I should say, the power of your processing, I should say, system. But I should say, all the thing that we had to do at this stage was that be able to create this multi-level hierarchical model for our Bayesian analysis for the Alzheimer, and the rest of it based on the things that you have learned on the level 1 and level 2 of the model, and how to execute the files then depends on you. But the purpose at this tutorial was that to show you how to create these blocks in your hierarchical models that we had then. I hope that at the end of these tutorials, you're able to implement and adopt Bayesian hierarchical models in your research or in the industry that you work, and be able to, based on the need, to add any levels of the hierarchy in your model using this stand file. It was a pleasure to just be with you in this wonderful journey, and I wish you best of luck for your study and research.